This lecture is about the Caret package, which is a very useful front-end package that wraps around a lot of the prediction algorithms and tools that you'll be using in the R programming language. So the Caret package can be found here at this website that I've linked to here at the bottom, or you can just Google Caret R package and you'll be able to find the package. The functionality that's built into the Caret package are some of the following. So for example, we can use the pre-processing tools in the Caret package to clean data and get the features set up so that they can be used for prediction. We can also do sort of cross-validation and data splitting within the training set using the create data partition and create time slices functions. We can also create training and test sets with the training and predict functions, and we can use those to train data sets and train prediction functions and apply them to new data sets. We can also do model comparison using the confusion matrix function, which will give you information about how well the models did on new data sets. There are a large number of machine learning algorithms that are built into R. So these range from very popular statistical machine learning algorithms like linear discriminant analysis and regression to much more widely used algorithms in computer science like support vector machines, classification and regression trees, or random forests and boosting. All of these algorithms are built by a variety of different developers, all coming from different backgrounds, and so the interfaces to each of these sort of prediction algorithms is slightly different. As one example of this, consider this class of different prediction algorithms that you could have applied, so everything from linear discriminant analysis down to boosting. And so for each of these different algorithms, you can imagine creating an object called OBJ in R. That object will have a different class, say a linear discriminant analysis or GLM and so forth. And for each of these objects, we can try to predict. And if we apply the predict function, we have to pass slightly different parameters each time in order to get the prediction of the outcome. So for example, from the GLM package, we have to say type equals response to get the prediction of the response from that model fit. Or for example, if we want to use rpart, we want to predict with type equals probability in order to predict the response. In each case, they're a little bit different, and the Caret package provides a unifying framework that allows you to predict using just one function and without having to specify all the options that you might care about in order to get the same prediction out. So here's a quick example using the Caret package. We'll go into the details of how this is done very specifically in later examples. So here we've loaded in the Caret package, and we've loaded the kernlab package as well to get the spam data set. And so what we can do first is partition the data set up into a training and a test set. Here I'm going to use the spam type, and I'm going to split it into the training set and the test set. I'm going to say we're going to use about 75% of our data to train the model and 25% to test. Then what I can do is I can actually subset the data into the training data using the inTrain the inTrain object that comes out from create data partition. And I can create the testing data set by finding all those samples that aren't in the training set. Then this will give me a subset of the data that are just for training and a subset of the data that are just for testing. And you can do this with sort of this simple interface. Next, you can fit a model. So here I'm going to use the train command from the Caret package. And so again, I'm trying to predict type, and I use the tilde and the dot to say use all the other variables in this data frame in order to predict the type. And I tell it which data set I want to build the training model on. And so in this case, the training data set that we created on the previous slide. And then I just tell it which of the methods that I'd like to use. And so you can use GLM, or you can use a bunch of other different models. And so what this does is it'll create a model fit from the train function, and this will use the 3,451 samples in the training set and the 57 predictors to predict which class you're belonging to based on a GLM model. And so what it can do is it can do a bunch of different ways of testing whether this model will work well and using to select the best model. And in this case, it used resampling, and it does bootstrapping with 25 replicates, and it corrects for the potential bias that might come from bootstrap sampling. So once we fit that model, we can actually look at the model. And so the way that you can do that is look at the final model component of the model fit object. And the way that you do that is you take the model fit object, and then you type $, and then always the same final model. It will tell you what is the actual fitted values that you got for that GLM model. Then you can predict on new samples by using the predict command. Again, it's a unified framework, so we just type predict. We pass it the model fit object that we got from the train function in Caret, and we pass it which data we'd like to predict on. So in this case, the new data is the testing data. When you do that, it'll give you a set of predictions that correspond to the responses, and you can use those to try to evaluate whether your model fit worked very well or not. One way that you can do that is by calculating the confusion matrix. So that's using this confusion matrix function. And so note the capital M here. Don't miss that when you're typing confusion matrix. Then you pass it the predictions that you got from your model fit, and then the actual outcome on the testing sample. So in this case, it was the type, whether it was a spam or a ham message. And then it'll report the confusion matrix. So it'll tell you a table for which of the cases that you predicted to be non-spam were actually non-spam, which are the cases where it was spam and you predicted it to be spam, and so forth. And then it gives you a bunch of summary statistics. So for example, the accuracy, a 95% confidence interval for the accuracy, and then a bunch of information about how well they correspond in other categories. So for example, the sensitivity and the specificity of that. So the confusion matrix function wraps a bunch of different accuracy measures that you might want to get out when you're evaluating a model fit. For a lot more information about Caret, we're going to cover a lot of it in this class in terms of how do you actually apply the Caret package. But I found that these tutorials are actually very nice, and they can be very useful for covering material that we don't cover in this class. And there's also a very nice paper in the Journal of Statistical Software that introduces the Caret package if you want further information.